With tethered power transmission from the ground, continuous operation can be achieved with multirotor UAVs, but a tether introduces additional forces due to its weight and aerodynamic effects. In static cases this is not a problem, but in real-world use, with wind and fast flight speeds, these forces need to be considered. The tether shape and tension forces can be estimated from the start and end positions and airspeed. For this we propose two methods, an analytical method based on catenary theory and a numerical method using discretized cable segments and point masses. Both methods are real-time capable with 0.5 milliseconds solve time for analytical and 5 milliseconds for the numerical method. Real-world tension measurements with a load cell were taken to confirm the correctness of both approaches. Here you can see the real-world test flights which were conducted at a flight height of 30 meters using a hand-drawn card for the ground vehicle. These plots show the simulation results for the test flight. While the analytical method is less physically accurate, it still shows close agreement with the numerical method. We observe a small difference between measurements and simulation due to unmodeled system dynamics and GPS altitude errors.